Well, welcome to our test prep video. We're going to put all our energy tonight into getting ready for tomorrow's big exam. We're going to kind of try to take a step back and take a look at all the log work we've done recently, along with some other random topics that showed up on the Wednesday quiz, and just walk through those solutions and talk our way through them and just focus on some of the finer details that are going to pay off on Friday. And so tonight's video is going to be devoted to going over Wednesday's quiz. I don't think there's any better indication of the questions we'll see on Friday than by looking at Wednesday's quiz. So without further ado, let's jump in. So our first question was actually our highest success rate. We demonstrated greater mastery of this question than any of the others, and so the title I gave this question was Solving an Exponential Equation. And the reason it's exponential is because of where the variable is located, and we used a particular method. Which method did we use? Because there's two methods. This was the method of common bases, and we used a base of 3 for each side, so that 9 became a 3 squared, and that was raised to the power of 3x plus 1, and the 27 became a 3 cubed. When in doubt, if you're ever having trouble trying to find a common base, always work smaller. Usually the smaller the better. Now we're going to use a product law right there, and we're going to multiply all the exponents. And basically we're saying the only way that these two expressions can be equal is if we drop the bases and set the exponents equal. So we've got 6x plus 2 is equal to 3x plus 6. Subtract 3x from both sides, subtract 2 from both sides, and x equals 4/3 is our solution. Of course, we could store that in alpha a or alpha x and just type in each side of the equation again just to confirm that they do indeed check. Now, we quickly transitioned from our most successful question to probably our most troublesome question yesterday. Notice my topic is still the same. I'm still solving an exponential equation. So it's kind of ironic that within the same topic we saw our best and worst problem. The reason it's exponential, again, is because of the location of the variable right there. And what I want to try to do is I want to try to isolate this term right here. Notice only the 5 is being raised to the power of 2x. So I want to try to isolate that expression. I'm going to divide both sides by 2, and that's going to give me 5 raised to the 2x equals 20. Unlike the last problem, though, I can't use the method of creating common bases. So the method that I'm going to use this time, and this is the number one thing I want you to focus on in your corrections, is just identifying the need for this method, is we're going to use a logarithmic approach where we take the log of both sides. We're going to take the log of both sides. And it's a weird move, but remember, the golden rule of mathematics is that whatever you do to one side, we do to the other side. So I'm going to take the log of the left side and the log of the right side. The magical part about this is that I'm allowed to move the exponent into the coefficient. Whoops, almost forgot my 5, equals the log of 20. Now what I'm going to do is I'm going to divide both sides by the log of 5. Alright, and that's going to give me a very strange decimal right here. And it's a strange enough decimal. I'm going to store it in alpha a so that I don't lose anything. And then I'm going to divide by 2. And my final answer, if I rounded it to the nearest tenth, I got 0.9. We were really, really strong here with question number 3. It's a logarithmic equation. The good thing is there's no condensing to be done. There was just one single log term on this side. So I'm going to go ahead and convert it to exponential right away. And in order to convert it to exponential form, I'm just going to go around the world. So I'm saying 27 raised to the 4/3 power equals the quantity 2x minus 1. Now, as far as evaluating 27 to the 4/3 power, I think we can certainly do it in our head. We'll just rewrite this using the groundhog rule. It's the cubed root of 27 raised to the 4th power. If you feel uncomfortable doing that, you're more than welcome to use your calculator. Just be very careful to type it in accurately. The cubed root of 27 is a 3. If I raise 3 to the 4th power, I'll get 81. And from here on out, it's a walk in the park. We're going to add 1 to both sides, and then we'll divide both sides by 2, and we get a beautiful 41. And again, don't be afraid to check these. Let's go back and check that domain. And this will come up later on in the video, but the domain says that this inner function has to be greater than 0. In other words, 2x has got to be greater than 1 and x has got to be greater than 1/2. And the solution that we got is certainly greater than 1/2, so it's a very keepable answer. Question number 4 here was probably the second most missed question, so I'm going to spend a little bit more time on this one. And so as we're condensing, I want you to think of the 3 logarithmic laws that we went over: the product, the quotient, and the power. And the first one I'm going to use is the power law. And that was something we tried to emphasize in our notes that night. And basically what that's saying is I'm going to grab these coefficients and I'm going to move them to the exponent on the respective terms, okay? So we're going to take nice baby steps here, and I'm going to just say the log of a raised to the 1/2 power minus the quantity, log of b raised to the 4th power plus the log of c raised to the 3rd. I think sometimes we get ourselves in trouble by trying to, bite off more than we can chew all at once. So just want to take some baby steps here. Now what I'm going to do is I'm going to clean up what's inside parentheses here, and I'm going to use the product law. All right, and the product law basically says that addition is going to morph into multiplication. And so, and you know what? I'm going to rewrite this term right here as radical a minus, and here comes the product law. I'm going to say the log of the quantity b to the 4th times c cubed. All right. The last thing that I'm going to do here is because of the minus sign, I'm going to use the quotient law. And this may be the trickiest one to practice writing. So again, tell yourself I'm only allowed to write the word log one time, big set of parentheses, and my numerator will be radical a, and my denominator will be b to the 4th c cubed. So just to reiterate, this is my numerator, this is my denominator, and we only write the word log one time. And that's my final answer. All right, here we go. Question number 5. They wanted us to expand, and again, I'm using the laws of logarithms just in the opposite direction. So the first move here that I tried to highlight was that, again, whatever we do to one side, we're going to do to the other. So I'm going to take the log of both sides right off the get-go, and I'm going to rewrite, instead of the cubed root of m, I'm going to just rewrite it as m to the 1/3. Divided by 8 times y. Notice the emphasis on times y, because there's a little bit of multiplication hiding in there that we're going to get to later. Let's see. I'm just going to continue to carry the log of x down. Nothing exciting is going to happen on the left side. It's just going to stay log of x the whole time. The first thing I'm going to do here is I'm going to jump on the quotient law right there. And I'm going to say the log of m to the 1/3 minus the log of 8 times y. Really emphasize, and don't be afraid to write that little multiplication sign. I think if we write that multiplication sign, it's going to help us identify the need for the product law, which is going to come next. And I'm also going to use, because of this exponent right here, I'm going to use the power law at the same time. So I'm going to try to kill 2 birds with 1 stone, if that's okay. So what would this look like? I'm going to say the log of x equals coefficient of 1/3 times the log of m minus, okay, now I've got this big set of parentheses, and I'm going to say the log of 8, which is the first term, plus the log of y. If you want to think of it, when you're using the product law, you can almost think of it as distributing the log to the 8 and to the y. I don't know if that helps at all. Technically, it's not the distributive property, but sometimes we can kind of think of it that way as a way of helping. The other thing is these parentheses are really, really important. What the parentheses tell me is with respect to the original problem, both the 8 and the y are in the denominator, and because they're both located in the denominator, I've got to have parentheses here. So this is my final answer. This might be the shortest, quickest one of the night. Who is your inner function? Or another way of asking ourselves, instead of saying who's the inner function, we could say, well, what are you taking the log of? And as you read this question, I would read it as log base 3 of the quantity x minus 8 minus x. So I'm going to say my inner function is the quantity 8 minus x. And what I'm going to instantly do for all of these is I'm always going to say my inner function is greater than 0, aka it's gotta be positive. All right, so in this case I'm going to say the quantity 8 minus x has to be greater than 0. I'm going to subtract 8 from both sides, and probably here comes the sneakiest step, is I'm going to divide both sides by a -1, and that causes me to flip the inequality sign, and the domain is all x values less than 8. And I think once we get just a little bit more practice with that, we're going to make that concept look really easy, and it's going to take, the next time you see that question on a quiz, it might take you, 10 or 15 seconds to answer it correctly. Here's another logarithmic equation, and this time we've got multiple logarithmic terms on the left side. So I'm going to go ahead and I'm going to condense those, and because of the minus sign, I'm going to use the quotient law right off the bat. So I'm going to say the log base 4, big set of parentheses. Don't be afraid to make your parentheses bigger than you've been making them lately in class. Then I've got, this is going to be my numerator. I'm going to change colors here. This is my numerator. And then this quantity here will be my denominator. So it'll be x squared plus 3x divided by the quantity x plus 5. Whoops, let's see. All right, and that's still equal to 1. And now I'm going to go ahead and I'm going to convert it to exponential. Make a little note to myself, kind of talk myself through it here. Convert to exponential. And all that means is I'm going to go around the world. So I'm grabbing the 4, I'm going to raise it to the first power, and I'm going to set it equal to this the entire red expression. And that gives me x squared plus 3x all over the quantity x plus 5. Whoops, x there, 5 there. Okay, now let's go ahead and we'll cross multiply. And you'll see this is kind of a longer problem. At this time, I'm trying to decide whether this is a linear or a quadratic equation. Since it's quadratic, I'm going to set it equal to 0. Just kind of move all the terms over to one side, kind of holding my breath, keeping my fingers crossed that it's factorable, and I believe, yes, indeed, it is. And now I'm going to go ahead and I'm going to tee it up. X equals positive 5, x equals negative 4, and now the big decision about whether to keep both of these solutions or whether we have to reject one of them or not. And all we're going to do is we're going to go back up here to the original problem, and we're going to ask ourselves, okay, if I substituted a 5 into this expression, would it be positive? All right, so, I'm thinking, is 5 squared plus 3 times 5, is that positive? Oh, yeah, that's really positive. Same thing goes for this expression here. If I plug a 5 into that, will I be positive? And the answer is yes. Now, let's redo the same process with the negative 4, and this is the one you're probably more suspicious of. And so I'm going to say, okay, negative 4 squared plus 3 times negative 4. Question is that greater than 0? Well, 16 minus 12 is greater than 0. So yes, let's try it again over here. Negative 4 plus 5 greater than 0. Yes, 1 is greater than 0. So we're keeping the negative 4. Kind of a rare occurrence here. Solution is positive 5 and negative 4. No rejections. There's no extraneous roots on this one. All right, question number 8. We're going to solve a rational equation. It's rational just mostly because of this fraction being involved right here. Because it's an equation, I want to try to clear out the fractions. I'm going to distribute an x to each and every term. So I'm going to wrap it up, and I'm just going to make a note to myself that I'm distributing an x. The first term will become x squared. The second term will become 2x. In the third term, the x's cancel, and we get minus 8. It is quadratic again, so we're going to set it equal to 0. Just be careful, watch your signs. We saw way too many mistakes with regards to, the minus there or the plus there. They did say a plus bi form, so that I made a mental note that I'm definitely going to use the quadratic formula here at some point, and I'm ready to do so right now. So let's say to ourselves, x equals, negate the b, plus or minus the square root of b squared, minus 4 times a times c, and that whole thing's divided by 2 times the a value. All right, let's buzz through the number crunching here real quick. 2 plus or minus the square root of, 4 minus 32 is negative 28. There it is. I'll tell you what, if we did not get a negative, you got to make sure you got that negative right there. We'd have been in trouble. I've got my I. Let's see, I'm going to break that into radical 4 and radical 7. So I've got 2i radical 7 all over 2. Got a GCF of 2. And that GCF is going to cancel with the 2 on the bottom. And my final solution is 1 plus or minus I radical 7. There it is, ladies and gentlemen, our solution. We did a really, really nice job with this factoring problem because there was a grand total of 4 terms. 1, 2, 3, 4. We knew it had to be factored by grouping automatically. And so we're trying to group the first 2 terms, and we're saying the GCF is x squared. And then divide that, that gives me 3x, divide there, minus 5, good. All right, now, I'm trying to pull out another GCF that's going to leave me with the same binomial. I'm actually going to divide by negative 16. Whoops, get that parenthesis going the wrong way. So if I divide by negative 16 there, I will get positive 3x. And if I divide by negative 16, I'll get minus 5. Yes, we've got a match. Now, what's the GCF of this term and this term? And don't be afraid to draw those squiggly brackets. It's going to help you stay organized. The new GCF is the quantity 3x minus 5. Parentheses are important. Divide the first term, you'll get x squared. Divide the second term, you'll get negative 16. And a lot of times you get to this stage of the game and you're all done. Unfortunately or fortunately, depending on how you're looking at it, we do get to do a little more factoring. A difference of two perfect squares. We go x plus 4, x minus 4. Now we're going to put our notation here that we are factored completely, ladies and gentlemen. Our last one on the quiz today, we're going to rationalize the denominator. And the big deal is, as you look at the denominator right now, because of that first term, because of that radical 3, we're very irrational. The method that we use is we multiply the top and the bottom by the conjugate of the denominator. So we're going to change the signs right there, and of course whatever I do to the bottom, I've got to follow that by doing it to the top. Okay, so I'm going to FOIL the top, and then we'll Florida style the bottom, because they're conjugates, we can cheat a little bit. So let's see, first times first is 3. The outer is going to be 5 radical 3. Oh my goodness gracious. I can't believe I just wrote that plus sign right there. Okay, so let's see if we can regroup here. Radical 3. The inner is going to give me 5 radical 3, and the last is going to give me plus 25. On the bottom, let's see, we got a 3. You could write radical 9, but I just say 3. And then I got a negative 25. We'll combine like terms. In the numerator, if I combine the 3 and the 25, I'll get 28, and then combine the 5 radical 3s, I'll get 10 radical 3 all over negative 22. I'm looking for a GCF here, and I'm going to pull out the 2, and that's going to leave me 14 plus 5 radical 3 all over negative 22. Reduce, and now present your final answer here. Let's go with 14 plus 5 radical 3 all over negative 11. You could distribute the negative through the top. That would also be equivalent, but you don't have to. All right, one more slide. So I got a special opportunity for you here as we get ready to take our test tomorrow. I think this is a great way to study and prepare for the test. I'm going to challenge you. Looking at the 10 questions, I want you to pick 3 of your favorite questions. I think preferably I'd like you to pick 3 that you missed. You know, when we talk about trying to get better and ready for the test tomorrow, pick 3 that you missed. And I want you to write 3 similar quiz questions. You know, like I said, use the questions that were on the quiz to inspire you. Be creative. Write your own questions. They don't have to be typed, but they do need to be very, very neat. And if you don't think your handwriting's up to par, then by all means go ahead and type them in Microsoft Word or something like that. You also need to submit an answer key, which includes the fully worked out solutions, okay? And if you submit those and turn those in with your test, you can earn up to 5 extra points to go along with your test grade going into break. So I think it'll be the extra effort will be worthwhile, not only for the points themselves, but I think it'll pay off and you'll get more questions correct on the test itself. So good luck tomorrow. Look forward to reaping the rewards of all your hard work. So we'll see you tomorrow.